Right. Hi, everybody. I am going to be talking about how much testing is enough testing. My name is Al-Jidy, and I am a software developer at Sky. And I'm really lazy. That's the important part about this talk. I think an important thing to set out, or just so we're on the same page, is why test. So here's a very, very long, slightly boring explanation of why we should test from the IS2QB website. So they're in charge of testing qualifications for software testing. So they should know what they're talking about. I'll go ahead and pick out the important parts of this. So software testing is necessary because we all make mistakes, and no matter how good a developer you are, no matter how much time you spend on your code, you're going to introduce bugs eventually. And more importantly, though, some of them can be expensive or dangerous. So that's really important from a business point of view. Bugs can completely ruin releases, they can completely slow down flow, and that's something that you want to insure against. But I noticed something really interesting from this that I disagreed with a little bit. We need to check everything and anything we produce. Now, like I said, I'm really, really lazy. And I don't know about you, but that sounds time-consuming, expensive, and slightly boring. So I started to question that. So if we're being told we need to test everything, how do we know what we've tested? There's quite a few metrics for this. Code coverage is like a very popular one, a very easy one. So if you don't know what code coverage is, it's basically something that you run against your unit test that you can write that basically say, and that runs against the code you've actually written, and it says the green lines are the tests. So you have a test that will examine that line of code, and the red code is where you have a test. You don't have any tests that will cover that line of code. So it gives you a very obvious example of how much you've actually covered, and they usually generate reports and percentages and all this sort of interesting stuff. So that's all well and good, but how much do you actually want to cover? So some bloke from Stack Exchange said we should aim for at least 70%. And I don't know about you, but Stack Exchange is the source of all knowledge for software, so I'm just going to believe him. But then I found another interesting pearl of wisdom. Ideally, you should be aiming for 100% code coverage. And that was from some Medium article. Now, everybody on the internet has access and opinions, so they can all write Medium articles. But, you know, I like them quite a lot. You know, it's a pretty website, so it must have some good opinions on it. So that's already a slightly differing opinion. And then I found another one. So that's Martin Fowler. He writes a software engineering blog. He does a lot of talks. And he said, I would expect coverage to be in the upper 80, 90%, but he'd be suspicious of anything like 100%. So Martin Fowler disagrees with this Medium article, and I was like, oh, well, that was the source of all my knowledge before this point. Now I've got to throw that out the window and start again. So I don't really like code coverage just by using it as a straight metric. So there's a couple reasons for that. It's really easy to fake and abuse, and what I mean by this is you can get to a point where you can start writing unit tests. Like if you've written 5 unit tests but you don't have 100% coverage, you can start adding in a few extra lines just to make sure you hit those extra lines, and it just means that your metric isn't really that. It's quite fallible, to be honest. You can use something called test coverage, which basically means you set out a load of test cases and you ensure that your tests are hitting all of those test cases. So that's a slightly better metric in that sense. The other thing is code coverage is like a really easy thing to take for granted. I've said test coverage in that little quote thing there, but I meant code coverage. So we have 100% test coverage. We don't need to do a regression. So that's something that I can really imagine like a release manager or a business person saying, just like hand waving away needing to do like a manual regression because you have 100% code coverage against a unit test. So it can be this thing that you can just point at and just use as a health check, which is a bit like, is not the best idea. So it's not a silver bullet. A lot of people assume if you have 100% code coverage, then you've tested everything, your code is great. It doesn't even say that the tests you've written to cover your code are even good. It just says that you've written a test to cover your code. I thought this was a lovely pearl of wisdom, another one from Stack Exchange, again, the source of all knowledge on the internet. So they said that it is a good metric to keep an eye on because it tells you what you have actually tested and what you haven't. But bugs can still come up and design can be really poor. Like, there's nothing that stops you from writing a bad unit test just because you have good code coverage. You know, you've covered every line, but that doesn't really mean anything at the end of the day. And the other thing is, if you're really aiming to get 100%, or if you have a code base that doesn't let you commit code unless you've hit a certain test coverage, what can happen is that last 5, 10, or 20% that you're trying to get, like, as you get towards that target, it gets like harder to hit. So the first 80% of like getting the code coverage might be reasonably straightforward, but the last 5, 10% might be those really random edge cases that might be quite hard to hit. So you can really kill yourself shooting for an arbitrary target. So I'll walk you through the scenario as to why I had to come up with this talk. So I was doing the graduate program at Sky to be a software engineer, and we were really inexperienced grads. I think I'd done some unit testing, a few other people had done some unit testing, but we didn't really know how testing worked in terms of like architecture scale. We had a completely brand new app, so we didn't have any architecture, we didn't have any test strategy, and we didn't have anyone smarter than us telling us what to do. And we were completely new to mobile development. If you've never done mobile development, I'll tell you something I learned. It's not like web development, it's very different. Don't assume it's the same. So it's like a completely different paradigm, it works in completely different ways, and there's completely different things to watch out for. So what I learned very quickly, and I think what all the grads learn very quickly, is testing on mobile is really, really, really hard compared to something a bit more simple. So firstly, we were making an Android and iOS app, so we had to test against both of those. You can't rely on anything that's in the Android OS or iOS, really. So you don't have any access to context or shared preferences or NS user defaults. So if you're not familiar with mobile development, those are basically somewhere where a mobile app can store little bits of data. You don't have access to that. So if you've got like the user's username stored there or their preferences and you want to access those, you can't access those during a test, which makes life a bit harder. There's a lot of things that are like impossible to mock, impossible to fake. There are these lovely things called parcels, which are a data structure often used in Android. And it left us with a case we'd write a test and then it just would never compile. And we'd start digging through and trying to fix all these little problems, but we never really managed to get there. And it tends to lead you to doing a lot of mocking everywhere. And how much do you mock? If you haven't done a lot about thinking about how you do your testing strategy before, like in our case, we had no idea what to mock. Do we mock everything? Do we mock nothing? I mean, we could have mocked everything, but probably shouldn't have. So to give you an idea of how we ended up solving this problem, this is the architecture for our code. So we were building a Xamarin app, which is a cross-platform app. So it means you can write one bit of code or 1.5 bits of code and then do it on Android and iOS and Windows and all the other lovely platforms there are. So in the middle, you have the shared code you write. And for us, we were using MVP, so that was our models and our presenters. So we'd get the data and we'd also interact with the views as well. And that was all done the same way on Android and iOS. But if you see over here, the Android and the iOS build, that was where the view logic was contained. So Android had activities and fragments, and iOS had view controllers. And what that basically allowed us to do is we could write one interface and make sure that Android and iOS were doing the same thing, but they were using like basically the same backend. It made things really, really quick. What we ended up doing was UI testing Android and UI testing iOS rather than testing the view logic on both. And we did that with Calabash. So Calabash is this really lovely tool similar to Appium or Espresso. Oh, that's really dark, I'm sorry. So as you can see, it's not very long. That's basically what I'm trying to show you. But and there's only 2 main functions on this thing, which is app wait for element and app.tap. So basically what you do is you expect something to be on the screen, and when it is there, you click. If it's not there or you can't click it, then you fail the test. So yeah, it's a really easy, quick way to actually write a UI test, which was really good for us lazy developers. So the positives of this approach was that we pretty much tested everything. Like, we did test our models and our presenters. Those were reasonably straightforward, so it was really easy to do those. We UI tested everything the view controllers and the activities and fragments should do. Now, the reason why I said code coverage earlier wasn't a very good metric was our code coverage was like less than 50%, which ideally isn't best because we're basically not testing one giant portion, but in reality, our UI tests cover everything they should do, and our backend should always be giving us back the same data. So we did manage to test everything without testing everything, if that makes sense. The other thing was, rather than fiddling around with like complicated Android mocking logic or iOS mocking logic for the UI tests, for testing the views, we made something in Calabash which is really easy to maintain and really easy to extend. It's very simple to understand. The negatives, though, these pretty much all stem from Calabash. Calabash isn't straightforward at all. I lied, I'm sorry. It's really complicated because of the nature of what it does. So unlike a unit test that sits in like an empty box with like barely any state, Calabash is running on top of a full iPhone or a full Android phone. You can have like race conditions, you can have all these sort of interacting side effects that you wouldn't get with a unit test. So it's not straightforward, I'm sorry, I lied. It's not fast at all. If anyone does any sort of automation testing, you know this. A whole suite, we had about 5 screens in the app, but the whole suite took about 15 minutes to run, which was great as a grad because we just played pool in that downtime that we had a lot of. And I think the most important one that would really hurt you on an enterprise scale is Calabash is not consistent. You end up with really flaky tests because of those side effects I mentioned earlier. So you'll hit run all tests, you'll walk away for coffee or for lunch or something, come back and you'll be like, the first one failed, we stopped running. And you're like, okay, thanks. And you end up with these really flaky tests that aren't the best. After a lot of finessing, you can usually get to a point where they're better, but UI, this approach wasn't basically a silver bullet again. But I guess the takeaway of this is, when thinking about how you're going to do testing, don't think you need to test everything by testing everything. Just test everything that you need to test, I guess. Cheers. Do we have time for questions?
Yeah, if you want. Do you want questions?
Yeah? Does anybody have any questions? Yeah?
Do you have any testers?
So a big part of that, which I didn't mention, was we were sort of time poor in terms of testing because there were 5 devs and we were all doing the testing basically. A big part of why we did the automated UI testing was that we didn't have to do manual regressions, especially because we were like inexperienced. We weren't sure of where we were putting bugs in basically, so we didn't know how often we needed to do a manual regression. So having an automated regression sort of saved us a lot of time. If we had more testers or someone that knew anything, we would have done that differently. Since then, we did do things differently on a completely different project, but it worked at the time.
Now that you're in an actual real mobile team and you know more, what kind of UI tests do you do now?
We use espresso tests. They're really flaky, so we don't use them, and they're really hard to maintain. We're aiming to change that. What we do there is something similar. We test the models and the presenters and sometimes anything that interacts with the views, but not the views themselves. Basically, if you're testing everything around the view, then it should work. We also have manual regressions, so that helps. Yeah, sorry?
So when you're getting to grips with mobile app development and mobile testing, was there a point when you thought, screw this, all this, all that we're doing is taking so long and it's very complicated, why are we bothering?
I think web was a lot simpler to think about. It had a lot less like baggage, I think is the easiest way to think about it. But there's a lot of things that I do really, really like about mobile development, and it's just like a new challenge. I'd recommend doing it if you haven't done it before, because it is like quite a different paradigm. Oh, sorry. Yeah, had we done a bit more reading, we would have learned that it is actually a bit more possible to mock a bit more on the view side. I think if we had less flaky Calabash tests, I think it would have been quite a good approach. It's just the fact they were quite flaky. So as the solution grew, as we got more and more classes, more and more tests, that was going to be like a problem. But,
when you said the devs were doing the testing,
yep.
were they doing any exploring or using the apps like the users would use them?
So part of the problem was like, because we were such a small team and it was such a limited scope, it sort of limited the chance to do exploratory testing and stuff. Like the thing didn't really do much in the end, despite having an awful lot of testing and code behind it. Yeah, we tried our best to do like manual testing that would actually like be exploratory testing and try and find something that we might not if we're just testing against test cases. But I think the main reason why we didn't do that much exploratory testing is just because the app didn't really do that much.
Okay, so it's like very tiny amount, if any.
Yeah, like, yeah, it was really small. Maybe we should have done a bit more, but yeah. Cool.
Is there any way to use developer tools when you're testing on mobile?
Developer tools, as in like...
To get console errors and network errors?
Yeah, so Android has this really great... I don't do that much iOS development anymore, if at all. Android has this really great tool called ADB, which is Android Debugging Bridge. It gives you like all the console errors you could ever need. There's a couple of really good tools. There's Charles, which basically is a man in the middle between an app and a network that you're using it on. So what you can do is you can see all the network calls that are going in and all the responses that are coming out, which can help. And there's also Stetho, which is, in all honesty, like the best one. What that basically does is you put a dependency in your app, and you can. It basically works like the web tools you get on Chrome and stuff like that. So you can see all the network requests. You can see how all the XML is made up, how the views are made up. You can see like profiling, so how hard the CPU is working. I definitely recommend Stetho, like stethoscope, but without the scope part. But yeah, cool. Thank you very much.